According to the International Building Code, laboratories are classified under two main occupancy types. Firstly, business occupancy, specifically assembly use, applies if the laboratory is open to the public or serves educational purposes. Secondly, research and development occupancy applies if the laboratory is used for scientific research, testing, or development. The International Building Code mandates emergency power for certain occupancies. Assembly occupancies must have emergency power to support egress lighting, fire alarms, and life safety systems. While research and development occupancies are not explicitly required to have emergency power, it may be necessary based on the specific equipment or processes within the laboratory. The International Building Code permits exceptions to the emergency power requirement for occupancies that do not pose a significant life safety risk. However, local building codes may impose additional requirements for emergency power in laboratories. Several NFPA codes offer further guidance on emergency power in laboratories. These include NFPA 101, the Life Safety Code, NFPA 70, the National Electrical Code, and NFPA 45, the Standard on Fire Protection for Laboratories Using Chemicals. Based on industry best practices, it is generally recommended to provide emergency power for laboratories that handle hazardous materials, use sensitive equipment, or conduct experiments that could create a significant risk to personnel of the facility. When planning for emergency power, consider several additional factors. Firstly, the type of emergency power off system needed, such as a generator, battery, or uninterruptible power supply, needs to be determined. Secondly, the acceptable transfer time from normal power to emergency power must be considered. Thirdly, calculate the power capacity required to support essential systems during an emergency. It is crucial to consult with local building officials and qualified electrical engineers to determine the specific requirements for emergency power in a laboratory setting. NFPA 70, the National Electrical Code, provides comprehensive standards for electrical installations, including emergency power systems. Article 700 covers emergency systems, defining them as those intended to supply, distribute, and control electricity for illumination, power, and signaling essential for safety to human life. These systems are automatically activated when normal power fails. Article 701 addresses legally required standby systems. These systems supply power to loads that, if interrupted, could create hazards or hamper rescue or firefighting operations. Article 702 covers optional standby systems, which supply power to non-essential loads. For laboratories, Article 500 through 516 may also be relevant if the laboratory handles hazardous materials, as these articles cover hazardous classified locations. NFPA 45, the Standard on Fire Protection for Laboratories Using Chemicals, provides specific guidance on fire protection and life safety in laboratories. Chapter 8 of NFPA 45 addresses utilities, including electrical systems. It emphasizes the need for emergency power systems to support critical equipment and processes, such as ventilation systems, fume hoods, and temperature-controlled storage. NFPA 45 recommends that laboratories handling highly hazardous materials have emergency power systems capable of maintaining essential functions during a power outage. The Life Safety Code, NFPA 101, provides requirements for emergency lighting and essential electrical systems in various occupancies. Chapter 11 of NFPA 101 addresses means of egress, requiring emergency lighting to illuminate exit routes during a power outage. Chapter 9 covers emergency power systems, specifying requirements for their reliability and performance. In laboratory settings, NFPA 101 ensures that emergency lighting and essential life safety systems are powered during a power outage, facilitating safe evacuation and maintaining critical functions. When assessing the need for emergency power, consider the potential consequences of a power outage. Evaluate the risks associated with the loss of critical equipment, such as ventilation systems, temperature-controlled storage, and monitoring devices. Consider the potential for hazardous materials to be released or experiments to be compromised. Assess the impact on personnel safety and the environment. The type of emergency power system should be chosen based on the specific needs of the laboratory. Generators provide a reliable source of backup power but require fuel and maintenance. Batteries offer a cleaner, quieter solution but have a limited runtime. Uninterruptible power supplies provide instantaneous power transfer but are typically used for short-term outages. When selecting an emergency power system, consider the following factors: the load requirements of the essential equipment, the duration of the expected power outages, the space available for the system, the cost of installation and maintenance, and the local regulatory requirements. The transfer time from normal power to emergency power is a critical consideration. Some equipment, such as computers and monitoring devices, may be sensitive to even brief power interruptions. In these cases, an uninterruptible power supply with a near instantaneous transfer time may be necessary. Other equipment, such as lighting and ventilation systems, may be able to tolerate a slightly longer transfer time. The capacity of the emergency power system must be sufficient to support all essential equipment simultaneously. Calculate the total power consumption of all critical loads, including lighting, ventilation, temperature control, and monitoring systems, as a safety margin to account for potential future expansion or unexpected loads. The emergency power system should be tested regularly to ensure that it is functioning properly. Conduct periodic load tests to verify that the system can support the required loads for the specified duration. Inspect the system for any signs of damage or wear. Keep detailed records of all tests and maintenance activities. Emergency power systems must be installed and maintained by qualified personnel. Electrical contractors and engineers with experience in emergency power systems should be consulted for design, installation, and maintenance services. Ensure that all work is performed in accordance with applicable codes and standards. Local building codes may impose additional requirements for emergency power in laboratories. Consult with local building officials to determine the specific requirements of a certain jurisdiction. Be aware of any permits, inspections, or other regulatory requirements that may apply. In conclusion, emergency power is a critical consideration for laboratories to ensure the safety of personnel, the integrity of research, and the protection of the environment. By carefully assessing the risks, selecting the appropriate type of emergency power system, and adhering to applicable codes and standards, laboratories can mitigate the potential consequences of a power outage. Consider that the International Building Code, or IBC, classifies laboratories based on their use. If the laboratory serves the public or provides education, it falls under business occupancy, specifically assembly use. If the laboratory is dedicated to scientific research, testing, or development, it is classified as research and development occupancy. Emergency power requirements are influenced by these classifications. Assembly occupancies typically require emergency power for egress lighting, fire alarms, and life safety systems. Research and development occupancies may not have explicit requirements, but the specific equipment and processes in use can necessitate emergency power. Exceptions to emergency power requirements exist for occupancies that do not present significant life safety risks. However, local building codes may introduce additional emergency power requirements tailored to laboratories in a certain area. Key NFPA codes offer valuable guidance. NFPA 101, the Life Safety Code, focuses on life safety measures. NFPA 70, the National Electrical Code, provides comprehensive electrical installation standards. NFPA 45, the Standard on Fire Protection for Laboratories Using Chemicals, addresses laboratory-specific hazards. Industry best practices strongly recommend emergency power for laboratories that handle hazardous materials, utilize sensitive equipment, or conduct experiments with significant potential risks. Emergency power planning involves several considerations. Selecting the right emergency power off, or EPO, system like a generator, battery, or uninterruptible power supply, or UPS, is crucial. Determining the acceptable transfer time between normal and emergency power is essential. Accurately calculating the power capacity needed for essential systems is also necessary. Consulting with local building officials and qualified electrical engineers ensures compliance with specific emergency power requirements for the laboratory. Article 700 of NFPA 70 extensively covers emergency systems. It defines them as vital for providing power for illumination, power, and signaling to ensure human safety. These systems automatically activate when normal power fails. Article 701 addresses legally required standby systems, which power loads whose interruption could cause hazards or hinder rescue operations. Article 702 covers optional standby systems for non-essential loads. Articles 500 through 516 are important if the laboratory handles hazardous materials, as they address classified hazardous locations. NFPA 45 provides specific guidance for fire protection and life safety in laboratories. Chapter 8 focuses on utilities, including electrical systems, emphasizing the need for emergency power to support critical equipment and processes like ventilation and temperature-controlled storage. NFPA 45 recommends emergency power for laboratories handling highly hazardous materials to maintain essential functions during outages. NFPA 101 addresses emergency lighting and essential electrical systems in various occupancies. Chapter 11 covers means of egress, mandating emergency lighting for exit routes during power outages. Chapter 9 outlines requirements for the reliability and performance of emergency power systems. NFPA 101 ensures that emergency lighting and life safety systems are powered during outages, facilitating safe evacuation and maintaining critical functions. Assess the potential consequences of power outages to determine the need for emergency power. Evaluate the risks related to losing critical equipment such as ventilation, temperature control, and monitoring devices. Consider the potential for hazardous material releases or compromised experiments. Assess the impact on personnel safety and the environment. Selecting the right emergency power system depends on the laboratory's specific needs. Generators offer a reliable backup power source but require fuel and maintenance. Batteries provide a cleaner, quieter solution but have limited runtimes. UPS systems offer instantaneous power transfer but are typically used for short-term outages. Key factors in selecting an emergency power system include the load requirements of essential equipment, expected outage duration, available space, installation and maintenance costs, and local regulatory requirements. The transfer time between normal and emergency power is a crucial factor. Sensitive equipment like computers and monitoring devices may require UPS systems for near instantaneous transfer. Other equipment, such as lighting and ventilation, may tolerate slightly longer transfer times. The emergency power system must have sufficient capacity to simultaneously support all essential equipment. Calculate the total power consumption of all critical loads, including lighting, ventilation, temperature control, and monitoring systems. As a safety margin for potential future expansion or unexpected loads. Regular testing is essential to ensure the emergency power system functions correctly. Perform periodic load tests to verify the system's ability to support the required loads for the specified duration. Inspect the system for damage or wear. Maintain detailed records of all tests and maintenance. Qualified personnel should install and maintain emergency power systems. Consult electrical contractors and engineers with experience in emergency power systems for design, installation, and maintenance services. Ensure all work complies with applicable codes and standards. Local building codes may impose additional emergency power requirements for laboratories. Consult local building officials to determine jurisdiction-specific requirements and be aware of any permits, inspections, or other regulatory requirements. Emergency power is crucial for laboratories to protect personnel, research, and the environment. Risk assessment, proper emergency power system selection, and adherence to codes and standards are essential for mitigating the consequences of power outages. When determining emergency power needs, it's crucial to consider the specific hazards and operations within the laboratory. Firstly, evaluate the types of chemicals used. Highly flammable, corrosive, or toxic substances necessitate robust ventilation and containment systems, which in turn require reliable emergency power. Secondly, assess the sensitivity of ongoing experiments. Power interruptions can compromise experiments, leading to data loss or safety hazards. An uninterrupted power supply, or UPS, might be essential to maintain critical equipment during brief outages. Thirdly, consider the function of critical equipment. Equipment such as freezers storing biological samples, incubators for cell cultures, and analytical instruments often require continuous power to prevent damage or loss. Emergency power is vital to maintaining their operation. Furthermore, it is very important to comply with local regulations. Building codes and fire safety regulations vary by location. Consult with local authorities and qualified engineers to ensure the laboratory meets all applicable requirements for emergency power. The National Electrical Code, or NEC, provides detailed guidelines for installing and maintaining electrical systems, including emergency power systems. Adherence to NEC standards is crucial for safety and code compliance. A risk assessment should identify potential hazards and vulnerabilities. Evaluate the likelihood and severity of power outages, considering factors such as the reliability of the local power grid and the presence of backup generators. Consider the potential consequences of equipment failure, chemical spills, or other incidents. Emergency power should be considered not just for immediate life safety, but also for mitigating long-term risks and disruptions. For example, emergency lighting in corridors and exit pathways is essential for safe evacuation during a power outage. But emergency power may also be necessary to maintain critical heating, ventilation, and air conditioning, or HVAC, systems to prevent temperature fluctuations that could damage sensitive equipment or materials. Documenting the emergency power plan is vital. A comprehensive emergency power plan should outline procedures for responding to power outages, including steps for activating backup systems, shutting down equipment, and evacuating personnel if necessary. Regularly review and update the plan to reflect changes in the laboratory's operations or regulatory requirements. Training personnel on emergency procedures and equipment is essential. Laboratory staff should be trained on the proper use of emergency power systems, including how to activate backup generators, operate manual transfer switches, and troubleshoot common problems. Regular drills and exercises can help ensure that personnel are prepared to respond effectively during a power outage.